Good morning, ma'am. I'm Sathvik of 19 MIS 107, ma'am, and my teammate is Akala Pradeep. Our project is on for natural language processing is on object detection for blind people with speech as output. So, coming for the abstract, this project tries to transform the visually world in the audio as well as the video with the potential to inform the blind people as well as their spatial locations. Object detection from these scenes are represented by their names and converted to speech. And these spatial locations are encoded into two-channel audio with the help of sound and simulation. Proposed idea: help the blind people to see better using the image to text and text to voice without any complex hardware. The features are implemented using the YOLO you look once algorithm that runs to the variation of extreme complex convolution neural networks architecture. This project tries to transform the visual world into the audio world with the potential to inform the blind people of an object as well as their spatial locations, and the object detected from these scenes are represented by their names and converted to speech. Their spatial locations are encoded into two-channel audio with the help of sound simulation. And the main objective is our goal is to begin to use artificial neural networks in the form of artificial neurons to teach our program what objects look like. In this case, we will use object images. We will train the data, which is further used to classify and identify the image by process. And the motivation for our project is many people suffer from temporary and permanent disabilities, like a blind stick man. That is, we can see we have pictures of a blind man having a stick, as well as a wheelchair, as well as the electrical wheel car, and the blind stick person, as well as the wheelchair and the electrical wheelchair. So here are the some scenarios related to our project. As we evolve from one generation to another generation, our needs and facilities are also evolved with us. So if you want to come up into a new technology for the blind people, as the technology is improving day by day, similarly, our project helps in these evolutions by providing a comfort to disabled who are facing obstacles due to their disabilities. Methodology: YOLO. You only look once is a neural network of object detection. That is, YOLO means that you only look once is the neural for an object detection, which consists of determining the location of the objects where certain objects are present. They classify the objects along with the class properties for the real-time applications. It uses the CNN network, that is a convolution neural network, for both localization as well as the classification of the objects using the bounding boxes. The YOLO design enables the end-to-end training and the real-time speeds while maintaining the high average precisions. Model description. Here we have two types of models, that is image capture, feature extraction, classification, object classification, as well as speech synthesis. The image capture. Here, what is the first step? Okay. The first step is that in the working of this blind sight application, the first important step is image capture. I mean, how the image has been captured from the webcam. That is the main and important step. Here, the image capturing is done with the help of processing the operating images from video, which have to be converted into frames. Okay. The live streaming, the live streaming is captured with the camera. So whatever the image capturing model is there, the image capturing model is mainly done to the webcam camera or the camera. So the camera which we use in the application is a webcam. So the image capture is done in the form of webcam. And next is the feature extraction. And after the second important phase, after the capturing the images is and having a group of images, we will then extract the features from those images. That is, feature extraction is the process of dimensionality reduction by which an initial set of raw data is reduced to more manageable groups of processing. Object classification. The object classification problem which tends to classify the different objects with the, it could be flowers, feces, fruits, or any other objects. I mean, we could imagine that if we can classify, as we all know that we can classify an object in the form of classification as clustering. The object classification process includes the following: finding the relative position. I mean, the many objects which has been captured has related many positions, and we have to find the relative position for that, and as having and also have the class identification with confidence. And whatever object which we have captured, have a confidence for that, and whichever has a more confidence one is given first priority, and whichever has a less confidence one is given the less priority, and then the object detection is done based on the priority order also. That okay. And next is done with the test description. And the test description, which may be of any language, etc. Speech synthesis. Speech synthesis is an artificial production of human speech. A computer system used for this purpose is called a speech computer or a speech synthesizer, and can be implemented in the software and the hardware products. It is a process of generating a spoken language by a machine on the basis of the written input. The speech synthesis involves the process of text analysis and the later the sound conversions. So the form of speech synthesis is to text to a speech. So the text to a speech is a process of converting the whole words, that is a whole number of words, whatever the words which are there in the project, I mean which are displayed in the form of an output, is converting those into the vocal audio forms. The program tool or the software takes an input text from the user, and using the methods of natural language processing, understanding the linguistics of the language being used, and perform the logical inference on the text. This process text is passed in the next block, where the digital signal process is performed on the process text. Using many algorithms and transformation, this process text is finally converted into speech format, and this entire format involves synthesizing of the speech. As we have a diagram where the text is sent in the form of natural language processing unit, and the natural language processing unit then from there it is set to the digital signal processing and is then converted into the form of speech, and this is called speech synthesizer. From the block diagram, we can conclude that the text being passed is firstly pre-processed with the help of natural language processing, and then using the digital signal processing is converted to speech. GTTS, the Google Text to Translate, is a Python library. And mostly the project is based on the Python, and we are using a Python library and the CLI tool to interfere with the Google Translate text to speech from the GTTS model, which can be used for speech translation. The text variable is string used to store the user input. The text can be replaced by any other form of choice within the quotes. And another alternative can be used to input statements for the user. Each time the program is run. The TTS variable is used to perform the Google Text to Translate speech on the user input, and the output is converted in the form of text and is stored in the form of speech in its variable. The TTS variable is used to perform the Google text to speech translation on the user input. The output is converted. So the output is converted to a text. The output is converted to the text and is stored in the form of speech in the TTS variable. The TTS.save function allows us to save the converted speech. The converted speech in the format that allows us to play the sounds. I have saved it in the form of .mp3, and other formats are .wav format and can also be used. We have successfully completed saving a file. Now there are 3 ways to file. I will go for those 3 ways. I mean, directly running the saved file from the folder. you can finally say you can find the save file from the same location and ran from your Python program. You can also access it from anywhere. And using an OS module, we can use Python OS module to directly run the file from the program. And this command do as follows. And next, the third one is like uh, using the place on module. The place on module can be installed with the help of simple PIP text tool, place on command, and then we can be proceed to play the audio from the file using the following command. And then from the conclusion is that the GTS module can be used as French, German, Hindi, etc. As well as this is an extreme useful when there is a when there is a communication barrier and so a user is unable to convey his messages to the people. Text to speech is a great help to the visually impaired people or people with other disabilities, as it can help them to by assisting the text to speech translation. There are also many other ideas possible with the GTS model as can be used for other languages as well. I mean, the GTS is like it helps to convert the speech in the form of a text. That is, a text is converted in the form of speech. So whichever language, whichever text is there, that's converted in the form of speech, and also used for conversion of that. I mean, the English is a globally accepted language. So whatever the object is detected is converted into English form of language. So the, from the go from the English for the in the English form of language, so it can be easily accepted by every other people. So it is a useful tool, and mostly it is in it is GTDS because we have used a Python library and our project is based on the Python. And the algorithm you only look once is a network of object detection that consists of determining the location of the object where certain objects are present. Classify object along with the class probabilities for the real-time application. It uses single CNN network for both localization and the classification of the objects using bounding boxes. The YOLO design enables the end-to-end training and the real-time spends while maintaining the high average precision. So this is a flowchart of the YOLO. I mean, first we start our program and we initialize all the packages and the libraries. And after the every package is started and initialized, the parameters, the weights, the modules, and threshold have been set. And here the weights are we use the W3 weights, and the threshold limit is we have a certain threshold limit in the algorithm, and we access the webcam from the frame dimensions. And whatever the image is captured, it is read in the form of frame, and we predict the objects from the frames. The bounding boxes with a class name with a conference and with value. We print the FFPS and we press the escape button for 30 seconds. If it is passed for 30 seconds, it doesn't get into any other loop. For every other loop, a new image get repeated. I mean, it is the live streaming of an images, and whatever images which is present in the present in front of the screen is gets repeated for every 30 seconds. So if you press escape for 30 seconds, escape for 30 seconds, the loop gets break. If not, the loop doesn't get break. And this is a systematic block diagram of a blind person. I mean, the blind person controlling the system with a hardware and software system. And the system detects whether it is human cup or fall. And that it in the form of speech text. And that text is converted in the form of a speech. So the input data. We'll be using our webcam to feed the images at 30 frames per second to this training model. And we can set it only process every other frame to speed up this. API. The class prediction of this objects detected in every frame will be string, example teddy bear. We will also obtain the coordinates of an object in the image and append the position. That is the top, mid, bottom, and left corner, right, and the other prediction cat. We can then send this test description to the Google text-to-speech API using GTDS package. Output. We will also obtain the coordinates of bounding boxes of every object detected in our frames. The overlay of the objects, the object detected, and return the stream of frames in the as a video playback. We will also schedule to get the voice feedback on the first frame of each second instead of 30 FPS. Example, bottom left teddy bear, meaning a cat is detected, that is a teddy bear has been detected at the bottom left of my camera view. So this is a methodology. That is, first the input image has been taken. It is divided into S into S grids, and the S into S grids have the grid cells, and each grid cell has the confidence level and IOU threshold score and truth prediction score. That each S into S dot has the bounding boxes as well as confidence, and based on the confidence and the probability only, the object is detected, whichever has the most high confidence is detected first. So this is how how an object detection architecture works. First, the image has been taken with the image has been taken with the help of what? Webcam. And those webcam helps to take the image acquisition. Is the images get stored, the images gets captured. And with the help of image being getting captured and using the TensorFlow object detection technique, that is Google text to speech, the TTS, and how the speech is the speech synthesizer, and it all comes in the TensorFlow object detection. And next, the object recognition is done. The object recognition is done based on that. Based on the confidence score, the S grids, and the bounding boxes only. The object recognition is done. So this is how our project works. Mainly the project is focused on the object detection, and how the object, whichever object is detected is and how that object is converted in the form of speech. How the object is converted in the form of text, and how that text is converted in the form and how that text is converted in the form of a speech. Yeah. Oh, thank you, ma'am. Thank you, ma'am. And this is our project of the NLP. Thank you.